Hi grade 8. We're on to topic 5 within fractions, which is division of fractions. Now most primary schools don't teach division of fractions because it's not in the primary school curriculum, and so I'm going to pretend that you've never seen this before. Some of you might have, but technically we're not meant to have done this before. So let's look at example 1. Now again, I would remind you, I would hit pause after we've done this example and copy it down because it's a really nice visual way of seeing what division means. So if the question in example 1 says, how do we simplify 3 divided by a quarter? Okay, now the question is, what does that mean? What that is actually saying is how many 1/4 are there in 3 wholes? Because you're taking 3 wholes and you're dividing it into quarters. So how many quarters would you have? Now I've drawn a picture of the situation. I drew 3 wholes. They could be cakes or bars of chocolates. And I've divided each of those 3 wholes into quarters. So how many quarters do I have? And you can see that I would have 4 in 1 hole, 4 in 2 holes, and another 4 in the 3rd hole, which means I basically have 3 sets of 4. So I have 12 sets of 1/4 in 3 holes. Now the reality is that if I was going to draw a picture for every time I needed to do one of these division questions, it would just take quite a long time. And so we start to lose a shortcut. And the shortcut is this. I said to you, my words were, I basically land up with 3 sets of 4, which is 3 times 4. So actually a division can be worked out by manipulating it into a multiplication. So in my little box I have our basically the kind of shortcut method that we're going to follow. And that shortcut is when we divide fractions, we don't need a common denominator. Now that's exactly the same as multiplying fractions. In multiplying fractions, we don't even think about a common denominator. It's the same idea as in dividing. Basically, we change the division to a multiply sign, and then whatever you're dividing by, you flip it round. So you flip the second fraction. So when I was at school, my teacher always used to say tip and times. So you tip the fraction that you're dividing by, and then you times them together. Now, why does this work? Well, because basically I have 3 sets of 4 because I have 4 quarters in each whole. And so it actually is a multiplication sum when you think about it in that way. So we're going to use this method as opposed to drawing pictures every time. So when you divide fractions, we change the division to a multiply, and then we flip the second fraction. So let's have a look at some examples together. So example 2. Don't forget to hit pause and write down steps and answers as you go. So simplify, and again this question says without a calculator. Now again, you can check this on your calculator, and I encourage you to check it on a calculator, but ultimately in the long run we're going to be doing questions in grades 9 to 12 which we can't do with a calculator, so we need to set up a set of skills. So how does division work? Well, division works, I'm going to change this to a times, and I'm going to flip the fraction I'm dividing by. So this becomes times 10 over 3. Note, nothing happens to the first fraction. So let me just write myself a note here. We basically change the division to a multiplication sign, and you flip the fraction that you're dividing by. Not the first fraction, so you flip the fraction you are dividing by. Flip the fraction you are dividing by. You leave the other fraction, or fractions if there was more than one, alone. So leave the other fraction alone. So don't start thinking that you have to flip everything. Okay, now what's wonderful about division of fractions is this has now been converted into a multiplication question. Now we've been practicing multiplication now for a while. So remember there was 2 methods. The first method was top times top, which is 1 times 10, which is 10. Bottom times bottom, which is 15. But then simplify. What goes into 10 as well as into 15? 5 goes into both of them, so if I divide the top and the bottom by 5, then effectively I'm dividing by 1, so my value doesn't change, so this becomes 2/3. Okay, or don't forget there's the tip and time method. And so tip and tie method, the cross-cancelling method, my apologies. Don't forget that there's the cross-cancelling method. And the cross-cancelling method was the one we said, right, 5 divided by 5 is 1, and 10 divided by 5 is 2. And now I'm going to do top times top, 1 times 2, bottom times bottom, 1 times 3. So you definitely just need to pick the method that works for you. Okay, let's try some more. 2 over 7 divided by 4. So don't forget that 2 over 7 is got nothing to do with division. So I'm going to change my division sign to a multiply sign as long as I flip around this fraction. Now here's the problem. 4 isn't a fraction. So let me make 4 into a fraction, because otherwise I'm not too sure how I'm going to tip it. So I make 4 into 4 over 1, so that when I flip it, I have 1 over 4. Okay, now I'm back to two different methods. Top times top, which is 2. Bottom times bottom, which is 28. Now I say to myself, can I simplify this? Well, I'd check on my calculator if I was being lazy, but I know I can because both of those are even numbers. So if I divide 1 by 2, so if I divide 2 by 2, I get 1, and 28 divided by 2 is 14. Okay, again, we could use the cross-cancel method, and that method is 2 over 7 times 1 over 4, and we say, is there something on the top and something on the bottom that can simplify? Well, 2 divided by 2 is 1, 4 divided by 2 is 2. So 1 times 1, top times top is 1, bottom times bottom is 14. And obviously I get the same answer, and either method is absolutely fine. Right, on to the next one. Well, this is testing something that we noticed in multiplying fractions as well. We never work with a mixed number. So my first step that I'm going to do is I'm going to change the mixed number to an improper fraction, because we do not like, they're not useful to work with at all. So this means I have 1 whole divided into 4 parts, which would be 4 parts plus 3. So there's 7 over 3 is that first fraction. Now, if I'm just trying to save space and time, I could change this division to multiplication in the same line, and then flip this fraction around in that same line. So do all my working. So this is now 15 over 14. Okay, now two different methods, top times top, and this is an example of where I probably wouldn't do top times top, because if I didn't have a calculator, I don't really want to work out 7 times 15 in my head. It is 105. Even 3 times 14 is quite an annoying calculation. So 3 times 14 is 42. And then deciding whether they're both divisible by something is quite difficult. I know that they're both divisible by 3 because I just used that trick that I've explained before. If I have a look at this, 1 plus 0 plus 5 is 6. And 6 is divisible by 3, so 105 is definitely divisible by 3. 42 is divisible by 3 because 4 plus 2 is 6, and that's divisible by 3. So if I divide the top by 3 and the bottom by 3, now I might not get to the simplest form yet, but if they're big numbers, sometimes I struggle. So I get 35, and if I divide 42 by 3, I get 14. I need to say to myself now, does that simplify any further? Well, I'd probably check on my calculator, but 35, oh, it does, I think. I think 7 goes into 35. So can I divide the top by 7 and the bottom by 7? Well, 35 divided by 7 is 5, and 14 divided by 7 is 2. And so finally I'm there. So there's nothing wrong with big numbers, just picking a number that you know goes into it and then simplifying it down and then simplifying it some more. It's probably why I would have chosen the cross-cancel method in this particular question, because it does make my life a little bit easier. Now the cross-cancel method here would have a little bit of work to do, because 7 divided by 7 is 1 and 14 divided by 7 is 2. So those two cancel together. Then 3 divided by 3 is 1 and 15 divided by 3 is 5. So finally I land up with 1 times 5, which is 5. And 1 times 2, which is 2, and I go straight to the answer, which, as you can see, because these were big numbers, it was a lot easier. Now, there's nothing wrong with exactly how I've written it out. It's very clear what cancelled with what, so as long as I can see what's happening in your method, that's absolutely fine. So don't cross things out in too much of a wild fashion. Okay, let's try another one. Oh gosh, 2 divisions, not a problem. And there's some negative signs, so not a problem. Let's first change these division signs. So this is negative 3 over 5. I'm going to change that division sign to a multiply. And I'm going to change this division sign to a multiply, as long as I flip the fraction around. So 7 over 6, and then as long as I flip this fraction around, which is 9 over 14, except I mustn't forget it's negative. So I might want to put that in a bracket, because otherwise it's just not visually very nice for the negative and the multiplication sign to be together. Okay, now again, this is probably an example of where cross-cancelling would work nicely, but let's do the first method first. Well, let's first deal with our signs. What's a negative times a negative? That's a positive. So I'm just writing that in there to remind myself. Oh, sorry, let me zoom out. Okay, now I've got 3 times 7 is 21. 21 times 9, and the sad thing is you might have to use a calculator to do that, is 189. Divided by 5 times 6 is 30, and then times 14 is 420. So these numbers are now really big again. Now I know both of those are divisible by 3 because I've done my little trick of checking, but that might not be the simplest form. And so often what we do is we cheat on our calculators, and if I cheat on my calculator I can get the answer of 9 over 20. Now let's just do it a little bit more slowly, because if it's said without a calculator, let's not use a calculator. So I divide both by 3, so 189 divided by 3 is 63, and 420 divided by 3 is 140. Now I think both of those are divisible by 7, so I keep going. 7 goes into 63 9 times, and 7 goes into 140 20 times, and I checked on my calculator already, and I know that's the answer. So it might have been a little bit easier for us to do a cross-cancel method in this case. So tip and times, and tip and times, and the one thing we've already discussed is the fact that a negative times a negative is a positive. So I always do my signs without even, doing the question. I just quickly multiply my signs together and get them kind of out of the way. Okay, now let's see. 3 goes into itself once. 3 goes into 6 twice. 7, if I change color, 7 goes into itself once. 7 goes into 14 twice. Now sometimes you're then able to keep cancelling the ones you would cancel. So now that green 2 could cancel with something else. Now that doesn't actually happen here, because now nothing else can cancel. So I get 1 times 9. Don't forget that I'd already multiplied the signs together, so I don't have to worry about them. 1 times 9 is 9. And at the bottom, 5 times 2 is 10. Times 2 is 20. And so I get the same answer. So again, probably a bit easier to cross-cancel in that one. Right. Again, a mixed number. The moment I see this, I see a mixed number, and I'm like, I don't want that mixed number. So it's a negative, so I'm going to ignore that for now. So 2 times 5 is 10. If you had 2 wholes divided into 5 pieces, you'd have 10 pieces. Plus 1 left over is 11 divided by 5. Okay, then let's change our division sign to a multiplication sign, as long as you flip the fraction next to it. Now that's also a negative, so I'm going to... didn't put my bracket in the right place, so let's do that again. You'll notice the question didn't have a bracket in it, but we do prefer to have a bracket separating a multiplication and a negative. Now notice I just flipped those fractions around. So if I was going to do top times top, bottom times bottom, let me first do my signs. A negative times a negative is a positive. 11 times 15 is 165, and 5 times 22 is 110. Now, definitely both divisible by 5, not divisible by 10. So let's divide by 5 first. It'll at least get a little bit smaller. So 165 divided by 5 is 33. And 110 divided by 5 is 22. Now, those numbers I recognize because they're both divisible by 11. So if I now divide them both by 11, I should get 3 over 2. So let's try other method quickly, our cross-cancelling method. So or negative 11 over 5 times negative 15 over 22. Put a bracket around it. Exactly the same concept in that a negative times a negative is a positive. So now I can ignore my signs. 11 divided by 11 is 1. 22 divided by 11 is 2. And then 5 divided by 5 is 1. And 15 divided by 5 is 3. So I land up with 1 times 3, which is 3. And 1 times 2, which is 2. So I go straight to the same answer. Great. We're hopefully getting the hang of this. So just a couple more. So this has multiplication and division in the same question. So we're starting to border on, like, what do I do first? And I think that confuses people. So don't forget what our steps are. Our steps are divide into terms, simplify each term, and then just move from left to right. Simplify from left to right. So divide into terms, simplify each term, and then you just simplify from left to right. So we're going to talk a lot about these three steps when we do order of work in fractions, which we're going to hopefully do soon. So if I have a look at this, how many terms? Well, this is one giant term, which means unless there's a bracket, I don't really have to worry about order of work. So what would I do here? Well, let me just sort out this whole division thing. So it's 6 over 7 times 14 over 18. So that had nothing to do with division. Now, I change the division sign to a multiplication sign as long as I go and flip the fraction I was dividing by. So 9 over 2. So now I just work from left to right. So I wrote down these three steps here so that we could start kind of remembering them. But I don't actually need that here. This is one term. But don't worry about do the division first, then the multiplication. It doesn't matter. You literally just work from left to right. So I would first change my division to multiplication because that's how I'm going to simplify. And then I just go left to right. So my top is 6 times 14 times 9. So this is probably going to be another better as cross-cancelling because 756 is a huge number. And then at the bottom, 7 times 18 times 2 is 252. And now I'd probably be really tempted to go and use my calculator to figure that out because that's a huge number. Now, I think they're both divisible by 3 because I just added up the numbers and checked. So again, if I didn't have a calculator, I'd have to go step by step by step. So if I divide top and bottom by 3, 756 divided by 3, what do you know, is 252. And 252 divided by 3 is 84. Now, I think they're both divisible by 7. And again, how do you know that? Well, I don't know. Let me just try. 252 divided by 7, what do you know, is 36. And 84 divided by 7 is 12. Now that's easy. Because 36 divided by 12, I know what that is. That answer is 3. So let's look at what the cross-cancelling version would look like, because I actually think it would be a lot easier. So 6 over 7 times 14 over 18 times 9 over 2. So what can cross-cancel? Well, 7 divided by 7 is 1. 14 divided by 7 is 2. Now, this is a great example of where you can see something dividing again, if you want to. So, for example, I could say 2 divided by 2 is 1. 2 divided by 2 is 1. So I could do that. 9 divided by 9 is 1. 18 divided by 9 is 2. And finally, if I really want to simplify fully, I could actually stop this now and just say 6 times 1 times 1 at the top and 1 times 2 times 1 at the bottom, and then simplify again. But if I really wanted to go the whole hog, 2 divided by 2 is 1 and 6 divided by 2 is 3. So I actually land up with 3 times 1, which is 3, over 1 times 1 times 1, which is 1, and 3 divided by 1 is just 3. So you don't have to keep simplifying and cross-cancelling. You can just cross-cancel a bit, then multiply, but then you must just check if you can simplify some more. Right, our last two questions are just on some word sums, which then become division questions. Now, it's fairly easy to do these now because we know we're doing division. The problem is when you hit a test and you don't know, am I adding, am I subtracting, am I dividing, or multiplying? So we need to read carefully. 5/6 of a pizza was left. Charlotte cut it into a number of pieces. each piece was 1/18 of the pizza. How many pieces did Charlotte cut it into? So basically she has 5/6 of the pizza left and she's cutting it into 1/18. So how many 1/18 fit into 5/6? Which basically translates to 5/6 divided into 1/18. So the first step is always to translate your words into a sum. Now we can solve this as we normally would because this is a division. So this changes to multiplication as long as we flip the fraction. If we use using the first method, 5 times 18 is 90, and 6 times 1 is 6. Those are both divisible by 3, so 90 divided by 3 is 30, and 6 divided by 3 is 2. Oh, but wait, 30 divided by 2 is 15, so there's 15 slices. That kind of makes sense. It wouldn't really make sense for me to get an answer that wasn't a whole number, really, because you can't really have a fraction of the piece left. I suppose you could if you cut it badly. So let's look at our other option, our cross-cancelling version. Our cross-cancelling version would just be the idea that 6 divided by itself is 1, and 18 divided by 6 is 3. So then I get top times top, which is 15, bottom times bottom, which is 1, and please don't leave your answers 15 divided by 1. That simplifies to 15. Right, our last question says the following. The mass of flour in a tin is 5/6 of a kilogram. It is packed into packets, each containing 2/9 of a kilogram of flour. How many packets of flour have been packed? Well, that means you have 5/6 of a kilogram, and I'm dividing it into packets of 2/9. So I'm going to change this to a multiplication question. So multiply by 9/2. So I have 5 times 9, which is 45. 6 times 2, which is 12. Now they definitely are both divisible by 3. So 45 divided by 3 is 15. 12 divided by 3 is 4. And that's as simplified as it would get. So, or how else could we do it? Well, we could say 5/6 times by 9/2, and then we could do the cross-cancel version. So we could say 3 goes into 6 twice, 3 goes into 9 3 times. Then top times top, 15, 2 times 2, 4. Now let's just think about this. That means she could not make a proper number of packets. 15 over 4, this is going to sound terrible coming out of my mouth, but let's change this to a mixed number. 15 divided by 4, well, 5 will go into 15 3 whole times. That would give me 12, and then I'd have 3/4 left. So basically there are 3 full packets, and then 3/4 of this 2/9 left. It's not 3/4 of a packet left, because just be careful, a packet contained 2/9. So there's 3/4 of the 2/9 left. So how many full packets can she make? She can make 3 full packets. She then has 3/4 of this 2/9 left. So what is the mass of flour remaining is the next question. So this is a really, really nice question. So let me just say this again. I didn't get a whole number of packets. So what it means is that I can have 3 full packets and then 3/4 of a packet. But just be careful, each packet contained 2/9. So what is the mass of flour remaining? Well, this means I have 3/4 of a packet, which is 3/4 of 2/9. Now that is 3/4 multiplied by 2/9. So really nifty. If I do the first method, 3 times 2 is 6, 4 times 9 is 36, and they're both divisible by 6, so I get 1/6 of a kilogram is left over. Okay, or if I'd done our cross-cancelling version, I could have said 3 goes into itself once, 9 divided by 3 is 3, 2 divided by 2 is 1, 4 divided by 2 is 2. So I get 1 times 1, which is 1, 2 times 3, which is 6. So really nice question. Simply because the answer wasn't a whole number, it meant that there was a whole number of packets and then some leftovers. Great. So hopefully that's enough examples to make us confident with our fractions. Yeah, well done.